So now we'll discuss what is Chebyshev inequality. Okay. So here for a given random variable x with the mean value x bar and the variance sigma x square, it states that the probability of mod x minus x bar greater than or equal to epsilon is equal to sigma x square by epsilon square, where epsilon is a very small positive number. Okay, so this inequality is defined by this statement. Okay, all of you should remember this statement. Okay, so this statement is called Chebyshev inequality. Whenever we have to find out the probability of a random variable such that probability of x minus x bar is greater than or equal to epsilon. Okay, so in that case, we will be using this this statement to solve that problems. Okay, so that is why this inequality, this statement is called Chebyshev inequality. Okay, where epsilon is a very small positive number. Now we'll see the proof of this. So here we know that the probability density function of a random variable is given as probability of x less than or equal to x is equal to fx of x. Okay, so that is equal to integral minus infinity to x fx of x dx. So this capital F is called probability distribution function. Small f is called probability density function. So probability of x less than or equal to x is equal to fx of x, and it is given as integral minus infinity to x. Okay, fx of x dx. This is the formula we'll be using. Okay, now we expand this equation. Now we expand this term. What is given in the statement? In the statement of Chebyshev inequality, it is given that probability of x minus x bar is greater than or equal to epsilon. So this we will be expanding now. So in the signals and systems also you have studied that how do you denote mod x. Mod x value will be taking two values depending on x value. Okay, so mod x will be equal to minus x for x less than 0. Okay, if x less than, for negative values, what is mod x? For mod negative values, mod x will be minus x. Okay, similarly for positive values of x, for positive values of x, what is mod x? Mod x will be x for x greater than 0. For positive values of x, it will be x greater than 0. And similarly here you see what is given. It is given that mod x minus x bar, okay, x minus x bar greater than or equal to epsilon. It is greater than or equal to epsilon. Okay, so for negative values, what is this value will be minus x bar. So modulus value will be negative for negative values of x minus x bar. Okay, so it will be greater than or equal to epsilon. Now if you multiply both sides with the minus 1, since you are multiplying with minus 1, what happens here? This will become less than or equal to epsilon, yes or no? So this becomes less than or equal to minus epsilon, since we are multiplying both sides with minus 1. Okay, and similarly for positive values, just now we have discussed what is the modulus for positive values. For positive values, modulus will be equal to always positive only. Okay, so what is that? Mod x will be equal to x for x greater than or equal greater than 0. Similarly, x minus x bar modulus will be equal to x minus x bar for the x minus x bar greater than 0. Okay, so this value will be positive. Okay, so here this value will be positive, and so that it will be greater than or equal to epsilon. Okay, so now what we have done, this mod x minus x bar is divided into two parts. What is that? It is given, so it is given that x minus x bar less than or equal to minus epsilon, x minus x bar greater than or equal to epsilon. Like that we will be dividing this modulus into two parts. So that is why the probability of mod x minus x bar greater than or equal to epsilon can be written as probability of, see here, x minus x bar less than or equal to minus epsilon, and probability of x minus x bar greater than or equal to epsilon. Here we have seen that probability of mod x minus x bar greater than or equal to epsilon will be written into two parts. That is probability of x minus x bar less than or equal to minus epsilon plus probability of x minus x bar greater than or equal to epsilon. Okay. So now we'll be sending that x bar. See here we have x minus x bar. No, we send this x bar to the right side. Okay. So what happens? This becomes probability of x less than or equal to x bar minus epsilon probability of x greater than or equal to x bar plus epsilon. Okay. So the equation what we have discussed in the previous case, that will be written like this here. It is probability of x less than or equal to x bar minus epsilon plus probability of x greater than or equal to x bar plus epsilon. Okay. Now we know that what is the formula for probability of x less than or equal to x. So what is the formula for probability of, see here, probability of x less than or equal to x can be written as, it is equal to integral minus infinity to x. Okay, it is minus infinity to x fx of x dx. So like this we will be writing this probability. Okay, now here what is that given? It is given that x bar minus epsilon, so it is integral minus infinity to, what is the limit here, x bar minus epsilon fx of x dx. See here it is x less than or equal to x bar minus epsilon, so it is integral minus infinity to x bar minus epsilon fx of x dx. Okay, so see this second term, this second term is probability of x greater than or equal to x bar plus epsilon. Since it is greater than, so the limit will start from x bar plus epsilon to infinity. Okay, so it is integral x bar plus epsilon to infinity fx of x dx. Okay, so now see here, so just now we have discussed that how do we write, how do you got this x bar minus epsilon, x bar plus epsilon. See, x bar minus epsilon and x bar plus epsilon we got from the previous case. See here, x bar plus x is that is x is less than or equal to x bar plus epsilon, x bar minus epsilon. How do you got? By taking x minus x bar greater than or equal to epsilon. So by taking x minus x bar greater than or equal to epsilon, we got two relations, that is x bar plus epsilon, x bar minus epsilon. Yes or no? So that is why, how do we write this? So now we combine these two. We combine these two limits. Now this can be written as mod x minus x bar greater than or equal to epsilon to infinity fx of x dx. Okay. So that is probability of x minus x bar greater than or equal to epsilon is equal to what? It is integral mod x minus x bar greater than or equal to epsilon to infinity fx of x dx. Okay. So now from the variance, we know that variance can be written as the sigma x square is equal to integral minus infinity to plus infinity fx x minus x bar square fx of x dx. Okay, so now what we do here, we divide this integral from minus infinity to plus infinity into two parts. Okay, so in the first part the integral is minus infinity to x minus x bar greater than or equal to epsilon, and whereas in the second integral it is mod x minus x bar greater than or equal to epsilon to infinity. Like that we divide this integral into two parts. The first part is minus infinity to x minus x bar greater than or equal to epsilon, whereas the second integral is from x minus x bar greater than or equal to epsilon to infinity. Okay, so in this equation what we do here, see here we have two terms, the first term and second term. No, now if you take only the first term, second term, if you take only the second term, what is sigma x square value? Sigma x square value will be always greater than or equal to the second term, because it is sum of two terms. Now we are not considering the first term. If you don't consider the first term, then what is the variance? Variance will be always greater than or equal to the second term value. Okay, so in this second term, what we do, we substitute x minus x bar is equal to epsilon. Okay, so what happens here? It is sigma x square is greater than or equal to integral mod x minus x bar greater than or equal to epsilon to infinity epsilon square fx of x dx. Okay, since epsilon is constant, we'll be writing outside the integral. Then sigma x square is greater than or equal to epsilon square integral x minus x bar greater than or equal to epsilon to infinity fx of x dx. Okay, now in the previous case we have discussed that, okay, integral mod x minus x bar greater than or equal to epsilon to fx of x dx is what? See here, integral mod x minus x bar less than or greater than or equal to epsilon to infinity fx of x dx will be equal to what? It is probability of mod x minus x bar greater than or equal to epsilon. Okay, so it is the probability of x minus x bar greater than or equal to epsilon. Okay, so what is that here we do? We just replace this integral. We'll be replacing this integral with the probability value. What is that? It is the probability of x minus x bar greater than or equal to epsilon. Okay. So from this, what is the probability of x minus x bar greater than or equal to epsilon will be less than or equal to sigma x square by epsilon square. Okay. So, like that, we will be getting this inequality. Using this inequality, we find the probability of any random variable x such that x minus x bar greater than or equal to epsilon will be always less than or equal to sigma x square by epsilon square. Similarly, Chebyshev's inequality theorem also states that probability of mod x minus x bar less than epsilon. Okay, here you see that what we have considered. Here we have taken greater than or equal to epsilon. So what is the reverse of this? The reverse of is less than epsilon. Okay, so less than epsilon will be always greater than or equal to 1 minus probability of x minus x bar greater than or equal to epsilon. So what is the probability of x minus x bar greater than or equal to epsilon here? Will be sigma x square by uh, epsilon square. Okay, for any epsilon greater than 0. Okay, so now we'll prove this here. So from total probability theorem, we know that what is the probability of x minus x bar less than epsilon plus probability of x minus x bar greater than or equal to epsilon will be always equal to 1. Okay, so from that we will be finding what is probability of x minus x bar less than epsilon. Probability of x minus x bar less than epsilon is equal to 1 minus probability of x minus x bar greater than or equal to epsilon. Okay, from Chebyshev inequality, we know that what is the probability of x minus x bar greater than or equal to epsilon will be sigma x square by epsilon square. So from this we can find out what is the probability of x minus x bar less than epsilon will be always greater than or equal to 1 minus sigma x square by epsilon square. Okay. Now we see the first case. If sigma x square is 0, if sigma x square is 0, see this equation. From this equation, we know that probability of x minus x bar less than epsilon will be equal to 1. Okay. And for any epsilon value, if epsilon is equal to 0, see here, if epsilon will be is equal to 0, then what happens here? We get probability of x is equal to x bar. Probability of x is equal to x bar, that is equal to 1. Okay, so see here, if epsilon is equal to 0, what happens to the equation? If epsilon is equal to 0, we get x less than or equal to x bar, x greater than or equal to x bar. So we are taking the integral minus infinity to plus infinity fx of x dx. So for integral minus infinity to plus infinity fx of x dx, okay, the value will be equal to 1 because it gives us what? It gives us the area under the probability density function. See here, if epsilon is equal to 0, what happens to this term? it is infinity minus infinity to x bar and x bar to infinity. Okay, so that we will be getting what is that integral minus infinity to plus infinity fx of x dx. Okay, what is that value? That value will be equal to 1. Okay, so we'll be getting what is that, if epsilon is 0, we'll be getting probability for x less than or equal to x bar will be equal to 1, or probability of x is equal to x bar, what is that, it is equal to 1. So if the variance of a random variable tends to 0, then what is the probability at the mean value tends to 1. Okay, so from this what we can say, if the variance is tends to 0, okay, what is the mean value we are getting? We are getting what is the mean value is 1. Okay, so if the variance is 0, the mean value will be 1. See the second case here. In the second case, epsilon is equal to k sigma x. Okay. So if where k is a real number. So from the Chebyshev inequality, what we know that the probability of x minus x bar greater than or equal to epsilon can be written as sigma x square by epsilon square. Okay. So from this, okay, what is epsilon here we are substituting? Epsilon we are substituting it as k sigma x. If in the place of epsilon, we substitute k sigma x. So probability of x minus x bar greater than or equal to k sigma x is equal to what? It is equal to sigma x square by k square sigma x square. So sigma x square will get cancelled. So we will be having 1 by k square. Okay. So from this we can say that what is the probability of x minus x bar greater than or equal to k sigma x will be always less than or equal to 1 by k square. Okay, so from this the probability of x minus x bar less than k sigma x, what is it is less than k sigma x will be greater than or equal to 1 minus what is the value we have for greater than or equal to k sigma x, that is 1 by k square, no. So that is why it is equal to 1 minus 1 by k square. Okay, so this is the probability for mod x minus x bar less than k sigma x. So it is always greater than or equal to 1 minus 1 by k square.